All right, hey everybody. I'm going to do notes starting for Unit 7, polygons. So first we're going to classify what a polygon is. So make sure you have these two pieces of paper. It goes along with our PDF for this unit, okay? So a polygon, let me make sure, is a closed figure formed by 3 or more line segments called sides. So in elementary school, obviously we learned a lot about polygons. You know, we have triangles, squares, rectangles, rhombuses, trapezoids, all that kind of stuff. So we're going to now dive into the sum of all of these different types of polygons. So the sum of measures of the interior angles of any polygon can be determined by the number of triangles that can be drawn within this polygon. So we're going to complete the table below and we're going to see if we can find a pattern, okay? So as we know from this whole year, a triangle has 3 sides. Obviously, the number of triangles in this polygon is 1. So the sum of the interior angles of this. Okay, sorry, I had to stop the video there. So let's go back to this. Triangles have 3 sides. There's 1 triangle in this picture. We know that the interior sum of a triangle is 180. So quadrilateral. If we draw a line from this vertex to every other vertex in this quadrilateral, we come with 2 triangles. So there's 4 sides, there's 2 triangles. So, all right, if we take 180 and we add another 180 to it, the interior sum is going to be 360. So what we did is we did 2 times 180 and we got 360, okay? Let's do a pentagon. If you do a pentagon, you have 1, 2, 3 triangles. So you have 5 sides, 3 triangles. So if we do 3 times 180, we get 540. Now remember, these are all degrees. And this goal is like lazy with her degrees. We know that. Hexagon has 6 sides, so if we have 1, 2, 3, 4 triangles, 4 times 180 is going to be 720. So if we see a pattern here, we always have 3, 1, 4, 2, 5, 3, 6, 4. So with the number of sides, it always seems like it's 2 less than the number of sides. So like 7, 5, so 5 times 180 is 900. We have 8 sides and we have 6 triangles. 6 times 180 is 1080. We have a nonagon, we have 9 sides. It would be 2 less. And the last one, 1440. So if you kind of see the pattern here, we always have whatever number of sides is, we subtract by 2, we have 180. So we can write a formula for this. So if n represents the number of sides of a polygon, then the sum of interior angles s can be found by using this formula. So our total interior sum is going to take the number of sides, subtract by 2, and then multiply that by 180. And that's our equation. So that's the equation you're going to use for every single polygon. So let's use this equation for the next couple of problems. 15 minus 2 times 180, plug it in the calculator, you get 2340. 21 minus 2 times 180, we get 3420. 48 minus 2 times 180, you get 8280. And 36 minus 2 times 180, we get 6120. Okay? Now, we probably haven't heard of this vocabulary word, but we know exactly what these polygons look like. A regular polygon is a polygon in which all sides are equal and all angles measures are equal. So if we think about this in a triangle, what triangle has equal sides and equal angles? That's an equal angular triangle. We're going to know that a quadrilateral that has 4 equal sides, 4 equal angles, that's a square. So we know what these are. This is just adding a little bit more of a math side to it. So the measure of an interior angle of a regular polygon can be found by dividing the sum of an interior angle measures, the total that we found, and dividing it by the number of sides. So if we have a regular pentagon, remember a pentagon has 5 sides. So if we do 5 minus 2 times 180, the interior sum is going to be 540. And if we want to find one of those angles, we divide it by 5. So the interior angle of that pentagon is going to be 108. So each angle in that pentagon is 108 degrees. If we do 18 minus 2 times 180, we get 2880 divided by 18 sides. So each individual angle of that interior 18gon is going to be 160 degrees. Okay? So we're going to now talk about exterior angle measures. So exterior angle measures are supplementary. So just like we talked about in other units, I'll draw the picture for you. These two angles here make a straight line. So we're going to find all of the exterior angles of each polygon here, and we're going to see if we can see a pattern again. So if you do 79 minus 180, we get 101. And then do it down here, 140. And same thing, 119. And now we're going to add up all of these angles. So if we do 101, 140, and 119, we get 360 as a sum. Okay? Do the same thing for a quadrilateral. We get 36 here. We get 104. We get 91 and 109. Add up all of these and we get 360. Is it a coincidence? I don't know. Let's try it again. We get 82, we have, we have 59, 93, 50, and 76. Add them all up, 360. Let's try one more and let's see. We have 51, 56, 68, 57, 63, and 65. Add these all up and we get 360 again. All right, so this is not a coincidence. So we can conclude that the sum of the exterior measure of any single polygon is going to be 360. So the sum of is 360 degrees. So we're going to do a couple problems with these just to get a little bit familiar with them. So what is the measure of each exterior angle of a regular hexagon? So if we think hexagon has 6 sides, okay, a regular hexagon means that all those interior angles are going to be the same. So if the interior angles are the same, the exterior are obviously going to be the same as well. So if we do 360, because it's a total sum of exterior, divided by 6, we get 60 degrees. What is the sum of each exterior angle of a regular 14gon? Same thing. We do 360 divided by 24, and we're going to get each one to be 15 degrees. If the exterior angle of a regular polygon measures 12 degrees, how many sides does this polygon have? So we don't have an equation that would tell us, okay, given the exterior angles, we do a formula and we can get the number of sides. We don't have that. I'm sorry, I don't even know what I'm talking about today. The disruption before that somebody came in my room kind of threw me off. The exterior angle of a regular polygon measures 12 degrees, so we can just do 360 over x number of sides is equal to 12 degrees. Multiply, 360 is equal to 12x, and we get x is equal to 30. Sorry, thinking of a different problem. And if the exterior angle of a regular polygon measures 40 degrees, how many sides does the polygon have? So if we know the exterior angle is 40 degrees, we have 360 divided by those number of sides, divided by, is equal to 40. So 360 is equal to 40. And we get x is equal to 9. So it has 9 sides. Okay. I think that's it. I'm just doing a couple lessons today, so get ready to hear parallelograms.